No worries. No worries.
No worries. No worries.
Okay. Good morning.
Good morning.
Any question about yesterday? Okay, today we are going to start the fourth topic. Okay, it's about probability. Have you ever studied probability? Yes. Then this will be really easy. Right? Here we will cover this concept, okay, that's what is probability. The difference between a random event or a deterministic event and operation. The probability of the union and intersection. Do you know the union? Do you remember? Union. And conditional probability. What probability is? How you define probability?
Chance.
Yes, chance is a quantification of the possibilities of an event to happen, right? For example, to win the lottery. Here in Spain, the probability of winning the lottery is this one. Very low. The probability of raining, for example, today is low. Or for example, the probability of pass the midterm.
Very high.
Very low. Okay, in science, we use probability for probability of cure a disease, the probability that a given individual suffers from a disease or a pathology, or the probability of suffering complication during a surgery. Okay. Easy. Where do we get the probability? Why we need in a statistic probability? Until now, we have seen descriptive Until now, we have studied descriptive statistics. Okay, how to describe the data. For that, we use the central tendency measure. Chart. Mean mode. We have studied the dispersion measure. which are
Standard deviation and variance.
variance, standard deviation, the variation coefficient, okay, and the location measure, which are what?
Percentile.
Yes. Right. The quartiles, 1, 2, 3.
What is in the dispersion measure? Can you repeat all the three, please?
This is the variance. The second one, the standard deviation, and this is the variation coefficient. This is the standard deviation over the mean. Standard deviation over the mean. For the location measure, we have studied the quartiles, the decile, and the percentage. Okay. What's the aim of the study?
What's the question? What was the question, sorry?
The aim, the objective of we describe the data, but what is the really aim of the study? The aim of statistics is to make prediction. Okay. Then we have another part of statistics, which is inferential. Once we describe the data, we go to inferential statistics. Okay? We use regression, do you know? Do you know regression?
Yeah. Do you know ANOVA?
I know how. No.
This is analysis of variance. We also have Bayesian models, hypothesis tests, etc. With this part of statistics, we want to do inference. Do you know what inference is? Inference is the same as prediction. Prediction is the same. And to do that, to do inference, we need probability. we do inference or prediction? Well, can I? Left side. Do you remember the difference between population and the sample? They will have the population. For example, the inhabitants of Spain, and we have also a which is a subset of the population. For example, the inhabitants of Madrid. Okay. Then we study sample, we apply the descriptive statistic and then the inferential statistic, and then we try to do prediction to the population. Okay. We study the sample because it's reduced, and then we try to make prediction for the population. Okay. Do you understand me? This is why we study probability. Can I? This is what I explained to you now. So, and in particular, we will study inferential epidemiology. So the probabilities, the quantification of the possibility of occurrence of an event. Now, some basic things. Okay. We have the deterministic experiment. Okay. A deterministic experiment is an experiment that you know the result of that experiment within a margin of error. Okay, but you can predict very well the result. On the other hand, we have random experiment. Okay. We don't know the result. You understand the difference?
Wait, so for deterministic, you know the result before you do it?
Yes. For example, if I throw this pencil to the floor and I apply the laws of motion, I can predict the point where the pencil. But in a random experiment, you don't know the result. Okay. And we use probability for this random experiment. Okay. Because we don't know in instance the result. Okay. Now some important concepts. Do you remember what is the sample space and an elemental event? Okay. Okay, for the sample space, I use this notation. Do you know the symbol?
Omega.
Omega. Like the O, but in the Greek. If you don't like it, it's very common to use E. But you won't. But for me, it's different. Okay, the sample space is the space of all possible results of a random experiment. Okay, sample space contains all the possible solutions of results of the experiment. Okay, and an elemental event that I will note with capital letters A, B, C. always happens that an event is always a subset of sample space. Do you know this symbol?
Belongs to.
Yes. A is included in Omega.
Wait, can you say it again, please? What does that mean?
Yes. This means that the event A is included in the sample space. Now I'll give you an example.
Wait, can you say it again? Wait,
Non, non, ça c'est l'élément de.
Ah, voilà.
Now, the sample space contains all the possible results of an random experiment. What? Yes. An elementary event is a single result. I don't know who makes this up. An elementary event is a single result. Or is a subset of the sample space and sample. What is the sample space of rolling a dice?
3, 4, 5, 6.
Yes. The sample space will be 1, 2, 3, 4, 5, and 6. Okay. A dice has 6 faces. An important thing is the notation. Okay. When we work with sets in mathematics or with events which are the same, we always use this bracket. This is our sample space, the experiment of rolling a dice. Okay? If I define the event A, which is an even number, even number. Yes, I define the experiment A to be an even number. So A will be good.
Wait, so what's that saying? The one on top of it?
What?
The old thing.
This?
Yeah.
This is the sample space.
Oh, thank you.
Yes, omega or E. So the event is included in the sample space.
Elementary event is in sample space.
What?
Elementary event is in sample space.
Yes. A is included
Yeah, okay.
in omega.
And A is the sign for elementary event.
What?
A is the sign for elementary event.
Yes. Yeah.
It is? Okay,
Yeah.
that's fine.
Okay, you understand? Following the same example, for example, what will be the event B? which is a number higher than 4. B is also included in real. Right. For example, element C, a prime number. Five. Almost. Do you know what a prime number is?
Yeah.
5 is a prime number.
And 2. 3.
3, 1.
One is not a prime number.
21.
Do you know what is a prime number?
It can't be 1.
By itself and
Then,
one.
in this sample space, what are the prime numbers?
2, 3, and 5.
Yeah.
2,
3 and 5.
3, 5. You understand?
Yeah.
For example, the event B, D, the event D, for example, even and prime.
Even and prime.
And prime. Even and prime.
2. 2.
The even and prime. Then, the only even number here, 2.
It's not 21.
What is B? 5, 6, 7,
Okay. The last one. Now, F. Multiple.
3 and 6.
3 and 6. Qu'est-ce qu'il a? Bruh.
Because 12 is the sample space. Then F is F. So all these events are included in the sample space. Always. And the last one. G is a number higher than 6.
There's no
Empty.
numbers.
0 is
Empty. Just empty.
G
No,
is
it's
number
empty.
higher than 6.
Yeah.
It's empty.
It's empty.
It's the empty set.
Bruh.
It doesn't have.
Isn't that a rough?
Yeah.
Yes.
That's all. That's the legal one.
Yeah, the empty set. There is no element here.
Yeah.
Don't do this. Oh. If you don't see a number higher than 6, here is not possible, right? Don't do this. Don't do 0. Okay? Because 0 is an element not of this sample space, but the empty set doesn't contain any element. You
What
understand?
does that sign mean?
That sign means empty set.
Okay.
No element. Then G. In this example, G is not included. Okay, do you understand? Question? No? Okay, the conditions for having a random experiment are the following. Okay? Okay, in a random experiment, every element of the sample space can be obtained. Okay. And before performing the test, all the possible results of the random experiment are possible. Okay. These are the conditions to have a random experiment. Okay. This is the sample of the license. Okay. Here. This is the sample space of the license. The person who did this used this notation. And this is the examples I told you now. The sample space of a license. And the event given.
It's the same as A, B, C, D.
Yes.
Do we need to write it with the same example? Or can we do it like you showed us before? Can we do it the same way you showed us before? We also have to write a C
For the exam, we need to. So we
This one is 1, 2, 3, 4, 5, 6. In the sample space of rolling a light. And this is.
Do we have to write C?
No.
You don't have to. Okay.
You want, do it. But it's not necessary. Okay, again, we can classify the sample space in terms of the number of events in the sample space. We can have finite sample spaces, okay? We have a finite number of events, okay? Example of rolling a light. We also have discrete infinite sample spaces. Okay, this is the case of discrete number spaces. you have an infinite number of events, or a very high number of events, but there is a one-to-one correspondent with the natural numbers. Okay, here we use natural numbers. Okay, for example, the number of blue boxes sold in Madrid is a natural number.
Yes.
Okay. And we also have continuous sample spaces. It's the same, you have an infinite number of events, but there is not a correspondences with the natural numbers. Okay, we use here what set of numbers we use for continuous things.
What does it mean by one-to-one correspondence can be made with natural numbers?
Yes, that you have good question that that you can describe the number of events using natural numbers. For example, the number of blue boxes sold in Madrid is probably a very high number. Okay, but you can count that number. I mean, for example, one box or one person. Okay, and you can measure using natural numbers. The difference with continuous sample spaces is that this correspondence with natural number doesn't exist. Why not? Because for continuous variables or sample spaces, the data is given in ranges. Okay? For example, this the weight of our cement. Then this can be, for example, between 60 and 80 kilograms, right? But you can obtain every number inside this interval. For example, 62.3. It's not a natural number, it's a real number. Okay, here we use real number.
What's the difference between a natural and a real number?
What?
What's the difference between a natural number and a real number?
Natural numbers are the numbers that you use for counting. 1, 2, 3, 4 are the positive integers.
And real?
Real are
Oh,
decimal, rational numbers, rational is
thanks.
more real. Set. Okay, do you understand the difference
Yes.
between discrete and continuous? Okay, how we obtain probabilities? How we calculate probabilities? Do you know Laplace rule? Laplace. Friends. Laplace. I don't know if I
Tu peux parler sur mon fait, je sais pas. Oui.
Do you remember?
No.
Laplace. Imagine that you have a sample space and you want to calculate the probability of an event A that belongs to the sample space. Then the probability of this event is given by the Laplace rule. Laplace rule tells us that the probability of an event is just the number of favorable cases relative weight
And
over the number of all possible cases. You understand my lesson? Okay, this is the Laplace rule. The number of events which are favorable to the number of favorable cases relative to a given event over the total number of cases. For example, imagine that you are rolling a dice. And the sample space is for a dice. What's the probability of obtaining the event A, 3, 4, 5, 6? Now I want to compute the probability of fate.
4 plus 5 plus 6
4, 5, 6. Then
4
Over 6.
times 5 or
No.
just it's time or
It's 3 over 6.
do you
It's 50%.
Laplace?
Yeah.
Okay. Yeah.
It is.
What are how many favorable cases?
3 over 6.
3 on the 6. 0.5. 0.5.
Okay. And if I define the event to be 5,
It's 1 over 6. 0.6.
you understand? This is the Laplace rule. For example, the probability of obtaining a prime number.
2, 3, 5, 50%.
2 over 6.
3.
What two numbers prime are here?
What was the question?
The probability of obtaining a prime number here.
3, 5,
How many
so
prime numbers
50.
are here?
3. So
What numbers are here?
2, 3, 5, 8.
Yes. And the probability of prime number. Okay. Because 2, 3, and 5 are prime. Okay. Now I am asking.
No, wait, can you? No,
Wait, sir, you say A was even numbers? You said it was even numbers?
No, A is 4, 5, 6.
Oh, but from before you said even numbers. Wait, 2, 4, 6.
Yeah, but this is the previous example. Oh, this is another example. I use CSA. But what's the probability of obtaining an even number here?
It's the same.
The same, because you have 3 elements that are even. Can I continue? Now? Yeah. Now I roll the dice twice. What is the probability of obtaining at least 1/6?
1 over 6.
1 over 6.
1 over 6, yeah.
But you add the base, you roll the base twice.
1 over 3.
What?
1 over 3.
1
Because
over
yeah,
1.
you could get it twice.
What's the
At least 1, 6. Yeah, so that's 2 over 12.
Right.
No, you don't have
I
to.
have a line, and I roll
No, you
it
Oh,
don't.
yeah, yeah,
twice.
true, yeah.
You don't have to. You don't have to get
Yeah,
it in
that's 2
both.
over 6.
Yeah.
Then, yeah.
You don't have to get it in both. So,
Right.
At least once.
twice that?
One over 6 is the probability of 1
No, it's a 2 over. So 1 over 6 plus 1 over 6.
yeah.
It's 2 over 6 is 1 over 3. Right?
Yeah.
My brain is working.
Very hard.
No, yeah.
Why?
No.
Why? 1.
Because the first time 6 plus 6 is 12.
Me.
You make things. Okay. At least 1 Maybe you are thinking, okay, the probability of obtaining 1 6 in the first try is
1 over 6.
and maybe you do the same for the second try and you add the probability.
Yeah.
Yes. This will be 1/3. You do this, then grade will be a 0.
No, that'll be
This is not how probability works, okay? This is not.
You have to multiply it?
But when you multiply, you have to get 6 in both.
Yeah.
So I don't see how that's multiplied.
But it's not.
How many favorable cases have we?
Wait, or you get like.
Is it 1 over 36 or?
That's if you get 2 6 left.
1 over 6 plus
Or you get like. The chance of getting 1 6.
Because you can get only 1 6 the first time, only 1 6 the second time, with bonus.
I want at least 1.
Yeah, but that's still increased.
Oh, we have to add.
Yeah.
That's still increased.
Yes, but
Or you get.
for example,
Wait.
I do
Don't confuse me. Or you get like a 6 instantly.
how
Or
many
you get
favorable cases?
5 out of 6 that you don't have 1 6. Get what I mean?
But you don't have.
Also,
Do you times them? Or?
Oh.
you can also like roll. You get like 5 out of 6 chances that you don't get 1.
Yeah.
But you have to roll 1. So that's 1
So you-
over 6.
How many
So you
favorable
could have
cases?
2 sixes.
You can only get.
Yeah.
Only get 2 6s at maximum, right?
No. Why?
You roll 2 dice.
You get.
I roll a dice, and then I pick the dice, and I roll it again.
You get to get 6.
2 dice.
Why?
Oh.
You have 1 dice, you roll it. You see the number, then you pick the roll, the dice, and you roll it again.
So is it 2 over 6?
You can only get 1
Wait, so you roll 2 times.
1 over
But then you can get like 1. You can get 6 in both times.
You can, yeah, exactly.
But then you can also get 1 like in one of them.
And you can, exactly.
Yeah.
So that is the chance that you get two sixes
It's 1 over 36.
is 1 over 66. No, it's
36.
30, wait. Times, true. 1 over 36.
And then you
Plus the times you get like
and
5.
then 5 over 6, and then that's squared.
How many
Right.
days?
Yeah.
How many days?
That is
So that's
Okay, so it's
oh, I can't calculate it.
you can have 6 at the second row, or you can have 6.
How many? Okay, you have
Non, mais par contre, non, en fait, allez, il faut parler en anglais.
you don't know. Listen to me. You don't know the answer. Then why is the possibility? You don't know the answer. Write the possibility. For example, I can obtain
Sorry.
1, 1. I
Yeah.
can obtain 1, 2.
Yeah.
1, 3.
That is not
1, 4.
makes sense, I guess.
5. 1, 6. Okay.
Make what?
Now 1, 2, 1. 2, 2. 2, 6. Okay. Now 3, 1. 3, 2.
You can get a 6 by 3 and 3 and 2 and 4 and 1 and 5. That's a 6.
Yeah.
So that's not right.
And then here we have 1.
Subtract 1 minus the and then you decide to do my
How many?
No, what?
7. No. 11. On this. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
How do we do it without having to draw this all out?
What?
How do we figure it out without having to draw out all of the possibilities?
You want this? 1, 6.
Yeah, but how can we work it out? Like,
There is easier way to make it not to try. Yeah. Ah, on does it now.
And then the probability.
Over 36, 11 over 5.
It's supposed to be times 2. It's not squared.
1 minus the case you couldn't get 6.
11. And what is that?
Because like
No,
this one,
the result. It's a result of that.
yeah, and that's 1.
10 times 2, yeah. If we got it right, then we got it right, then
Yeah, but it's just like times 2, not squared.
yeah. Yeah. Fair.
That was difficult.
Actually, we did it the short way, I think. Yeah, we did it the short way. That is a
That is a lot.
Do you have another technique?
Yes, there are. Yeah, we are going to study Laplace rule. Favorable cases over total number of.
But can you do it without writing out every possibility?
What?
Like, how do you do it without writing out all the possibilities?
Yes, yes. Let me complete. Yes, this is an example. Okay. But do you understand? Laplace rule. When can we apply Laplace?
When we apply what?
Laplace rule?
Yeah, Laplace rule, this rule, yes, favorable cases over total number of cases. When can we use that? Yes. When the sample space is finite and where all the events are have the same probability. All the events must have the same probability. Okay. If not, you cannot apply Laplace.
All the events have the same probability.
Okay? No, this is essentially the Laplace rule. Okay, is the favorable cases, and n is the total number of cases. Okay? If we toss a coin and we want to obtain head or tails, this experiment is both results have the same probability. Right? And in the last example, each number has the same probability. Every number, then we can apply.
Tu fais P de 1 moins. Enfin, P univers moins P de 1. Putain, le truc de P qui est réel.
Right.
Ah,
Feliz.
yeah.
We're going to calculate.
10 over 40.
Yes, you know it. Favorable cases is not very favorable. Over. Okay. The Laplace rule is odd. Now, probability okay, this is unique. Laplace rule is good, but it's odd. Now, currently, probability is an axiomatic theory.
Mais j'ai révisé que
axiom is?
Zero.
Do you know what an axiom is?
Maybe the CNT.
No, I don't
Like,
C'est une property, no?
Assumption.
It's a property.
It's not a property, but an axiom is like a statement, okay, that is always true, and you don't need to prove it because it's your basis to develop a theory. Okay? You depart from your axiom and you build your theory. Okay, this is an axiom. Then probability is based on three axioms, which are known as the
Probability is based on that answer.
what? Yes.
Probability is based on that.
It's based on the Kolmogorov axiom.
Okay.
Yes. Russian cat, I think. But what the axiom are that probability. Okay, assume that we have a sample space and an event A that is included in a sample space. Okay. Then the axioms are the following. The probability of an event A the probability of an event A is bounded.
Tu sais que dans une heure, on a terminé.
Do you understand this?
what is bounding?
Bounded.
Bounding?
Bound. Do you know what bound?
Can you say it as well?
The first axiom is that probability is bound. Okay. Probability you take element of the sample space and the probability always returns you a number between 0 and 1. Probability is always larger than 0 and smaller than 3,000.
Surrounded by three numbers.
That's just the probability will always be zero.
Yes, if you in the exam obtain this,
You know when I was walking it's not so fun. It's
you
not disgusting.
you obtain this, you are fine. I mean, probability always between 0 and 1. Okay. You want a percentage, multiply by 1.
He's saying that like the rule for probability is to have a value over one. So
Why did we have to write it in language?
Second axiom.
But it makes sense.
Axiom is the property that says that when you have this, it's
Second axiom is that the probability of the sample space
One.
is always
maximum.
There's always one for the axiomatic theory. So it means
theory is based on this axiom. Always the probability of the sample space is 1.
axiomatic theory is already.
Why? Why do you think that this is?
Because the entire
All the possible results of the experiment belong to the sample space. Okay. Good. No.
But what is boundary? I'm sorry.
Bound is that in this case probability is between two values. In this case 0 and 1. You obtain a probability higher than 1, but if you obtain a negative probability, win. Okay,
That's what I chose.
and the last one, the last action, we will work on this action later. But given two events, A and B,
Wait, there's three different types.
Yes.
given two events, A and B, such that the intersection
That's quite easy.
is the end
Oh,
result.
it's 100%.
They're mutually if they're mutually exclusive.
Then
Times plus is plus.
It's just the last one, right?
this is the third action.
Yeah.
If you have two events such that the intersection is the empty set, then the probability of the union, not the intersection, of the union is the sum of the probability of each event.
And we can also like P A is the little B, you know. No, to explain it.
No, not right.
No, we will set.
I am figuring out.
No, we will set here now.
This is the third action. Only if this happens, then the probability is different. What happens if this is not satisfied? Remember?
You minus the thing.
How we will
If it's not 0,
One moment.
If there is an
This
intersection,
is not 0.
the
Okay?
probability is just this plus
It's
this.
the empty set. It's the set that doesn't contain any element. Okay?
wait, Tanya. If it's not,
So he's saying that if there is no intersection, so there is no and B, so we don't do
And
that.
now
They're just
we
two
will
separate
study what
circles, the
the
total
intersection and the
is
union
A
are.
plus B.
So now, currently, no. This point or every point?
the first one. No,
this is
You don't understand this point. Okay.
no, this is
Can I?
this one or
Yes.
yeah.
Yes. Currently, probability is an axiomatic theory, okay, which is based on three assumptions. The first one is that probability is bound, is always between 0 and 1. Do you understand what this means? And then probability is between 0 and 1. For example, you can obtain
So if you take
0. Because between 0 and 1. If you obtain this,
So the first one.
yeah,
First example.
yeah.
for example, very bad. Because probability is always between 0 and 1. This is larger than 1. you are outside this range. Okay. Then this is not a probability. You obtain this, you are wrong. Okay. You have to check the exercise. And you obtain this,
What kind of question?
then you fail all. Okay. No negative and also no larger partition. Okay. This is the meaning. The mathematical form to write this. But it's the same. Okay.
So it's.
Do you understand the second one?
It can't be more than one or less than zero.
If you find something like more than one, there is a
Understand?
problem and you have to correct it. Or if you have something negative,
What is the
it's
sample
not
space? The sample space contains all the possible results of an experiment. Okay? For example, if we roll a dice, the sample space is 1, 2, 3, 4, 5, 6. You understand why? This means that the probability of obtaining a result inside this set is always 1. What's the probability of obtaining a number between 1 and 6 when I roll a dice? What is the probability of obtaining a number here? 1, because it's sure that you will obtain a number between 1 and 6. This means the probability of the sample space is always 1. And the final one, I will explain you later. Okay? Give me a moment. I explain you now. Okay. Let's study now the possible percentage events. This is wrong. I think I checked and the slide.
No, it's not.
No, it's not.
She said like before the
Oh yes. King, this is what I explained you now. No. Go on.
We don't have it.
Okay.
It's like
Okay. This is what I explained you now. An impossible event is represented by the empty set. Okay? You don't have. Okay, impossible. An impossible event is never secure and you represent it by the empty set. Okay. I'm telling you that this thing doesn't make sense. Okay, this. I think I'm correct. Correct? No.
It's
I correct it in your slide, but not in.
I'm not sure. Maybe she
A probability is not a
say.
set, it's not an empty set. Okay. In my slide, I have. Okay. This doesn't make sense. Here you are telling that the probability is an empty set. This doesn't make sense. Okay. So this is wrong. And I correct your slides, but not mine. Okay. In your slides you should have this. Yeah. Yes?
So we use this one just to say at the end, just we use this one, we never use it in the calculation.
Yes, the proper way.
The 0 with the 1.
Yes, here we are studying possible events. Okay.
When we put it in the sentence, I mean, why do we introduce a new symbol? Do not use it.
This.
Why do we use this symbol? Yes, impossible.
This symbol is used when the event is impossible.
Yeah, when we use it in a sentence, in an example, for example. We say P equals 0, so.
No, for example, A is an event. A, B, C is an event. An event.
It says between 1 and 3, and we want the probability to obtain 4. It's impossible.
Yes. But, yes, that's correct. But here in the slide,
We will
you
say
have
P.
this. This doesn't make sense
Yeah.
because probability is not set. The correct form to write it is that probability is 0, but not this.
So you will never write this one.
In a probability, no.
Okay.
But in a set, you can have the empty set.
Okay, good.
Okay? But not in a probability. Probability is a number, not a set. Okay. Yes. Do we continue?
C'est-à-dire que s'il y a ça dans l'examen, on va avoir.
Okay. The complementary of an event. You remember what is that?
Un élément ici. D'accord.
Okay.
C'est l'examen de la semaine prochaine.
Quoi? The complementary of an event is the event that
Open
occurs when A doesn't. Okay. I mean,
Non, open question.
imagine that you have rolling a line, okay? Then the sample space is 1, 2, 3, 4, 5, 6.
Mais ça, je connais. Je connais pas.
If I define the event A to be an even number,
Non, ça, ça va. Je vais s'en passer.
I have this, right? This is all the possibilities of rolling a line from 1 to 6. This is the event of obtaining an even number. What is the complementary of this set?
The remaining numbers.
Yes, yes. The complementary is the opposite to A. In this case, 1, 3, and 5. Okay. And from the reaction before you obtain this result. Okay. The probability of an event plus the probability of its complementary is always 1. Okay.
But it's related to what we did in the one.
It's obtained by the reaction before. By this logic. Right?
So we can say that it's equal to omega. It's equal to P of omega now.
What?
PA is the opposite of A. It's the P of the omega now.
Yes, this is also P of.
Just to understand.
Okay? This is the complementary. Okay, for example, in these two,
If you have
this example, We toss a coin, the opposite event of taking a head is taking a head. Okay, an example. Imagine that you have this exercise in the exam. Okay? Find the individual probability of randomly selecting a patient who is not between 50 and 60 years old, having income the next four. How do you obtain this probability without looking at the PowerPoint?
It's just 156 over the total.
Yeah.
Just,
Divided.
just yeah. 156 over the total, I think.
Would you like to work out the probability of 50 plus 65 and then just 1 minus that?
Yes, you can. You can use the plus rule. How can you apply the Laplace rule here?
Add together all the ones. Do 975 minus 156, and then divide that number by 975.
Yes, the Laplace rule is number of favorable cases over total number of cases. Then, if you use the Laplace rule, the probability is
975 minus 165.
This is the probability for between the 50 and 65, right?
Yeah.
yes.
So it's
Laplace
156
rule
on
is just adding like between the 18 and 22. Then
But you want the okay, so the complementarity.
Yeah.
Ah,
okay.
Because it's not between.
but so we made the 156 on 975.
One minus the percentage.
La Laplace rule.
C'est juste
Yeah.
Et ça,
This
c'est
is a method.
contrariable.
Bah oui, mais c'est ce qu'ils veulent, au contraire, il y a là-bas.
Using the Laplace rule,
P8
here
plus
to
P
if
with
you have
You have to add like 195 plus
Non, moi je vais faire des plus simple.
mais
Oui, mais moi j'ai fait la test rule, mais en beaucoup plus simple.
En fait, tu le fais avec le contraire.
Oui, mais moi j'ai le contraire.
Ok, mais il y a deux méthodes pour le faire.
Like he says, opposite would be
yes,
in
yes,
a steady way, it's like
yes.
more fast.
Yes.
Just we at the end we just minus the
Yes. I mean, you can use Laplace rules,
in both.
but you can use the complementarity. Okay? Then you can obtain the probability of being between 50. Okay. Which is, what is that?
156 on 975.
And then you have
1 minus P 0
the same.
Yeah.
Okay. You have to make. You choose whatever you want. Okay. Good. continue a little bit more.
Because it's like one is the total. And now we're looking for
Okay, you have.
probability of every
You can use the complementary or the absolute.
So not the probability P of this is only
Okay, let's see the intersection.
so if we do 1 minus this or this. But there is 3 ways of doing this.
What is the intersection of two events?
A and B.
A and B. You know these diagrams?
Yeah.
Are called Venn diagrams. Okay, you have two sets, A and B. The intersection is experiment is in the intersection of A and B. The intersection is in A, but also is in B. Okay, it's the common thing between A and B. You
The
understand?
other one is
The union. Yes. So this is the intersection. For example, I don't know. A is this and this. What is the intersection of these two sets?
3 and 5. 3 and 5.
3 and 5. Because 3 and 5 are composing. Sets. Yes. It happens in A and B. It's like an and. You can have this and this. This union is not one. It's different from one. But here we have two elements. Okay? Then the intersection is not. Yes. In this example, intersection has two elements, right? 3 and 5. Then intersection between these two numbers is not. Why is not that? This is because the intersection is not yes, because we have two elements.
Of course, why do we write that? It's obvious.
Yes, so. You can also have something like this. A.
Yeah, now this one is this one. This one is
Yes. Here, the intersection is not empty because we have two. Here, we have two events that never touch each other. For example, what is the intersection for these two sets?
there is no.
No.
Zero is doesn't exist.
It's not zero. It's the empty set.
We have probability of here.
Yes, probability.
Nice and early, well done.
If they don't have an intersection, freeze.
No.
Can I continue? And the union. What is the union?
Union is everything, no?
Now consider that you have two sets. Yeah. The intersection is that it can use in A and also in B. Is this? This whole thing is the intersection. Okay. The elements that are here are in A but also in B. The intersection. Okay. Yes or no?
Can union be same as P of A union B and P omega? Because it's everything. No, in the last slide we saw yeah, exactly. So it can be P of omega. P A union B.
It's not P of omega.
A union B is not all the numbers that are in A and B. It doesn't exist on there.
Union is A or B.
No, I'm not talking about intersection. It doesn't include
And it also doesn't
intersection.
it also doesn't include events outside.
You can have an element.
No, I'm not including intersections, but I'm talking about unions.
Yeah, but union is only A or B. It's not necessarily. It's like all of A separate or all of B.
Wait, sir, does A and B belong to A U or is it separate? What? You know A and B, does it belong to A U?
And but the main thing is it doesn't include outside of it.
This is the intersection
Stuff outside.
It's in A, but also is in B. Now,
A union B is not 2, 4, 3, 6.
Yeah, no, you're right. It's all of it.
what's the union?
Because outside of it.
The union is the elements that are in A
There was like yeah, but
or that are in B.
so there could be A, B, C, D, E, F. You're only looking at A, B. And then C, D, E, F would be outside.
When I'm talking omega, A union
Yeah, yeah.
because union is A and B. If A or B.
If omega was just A, B.
Okay.
That is it.
The union are the elements that are in A or in B or in both. Okay? But this is not.
If you only have A and B and no other elements,
Yeah,
then it's right.
Do you understand the difference between intersection and union?
Union is D is all.
Intersection are the elements that are in A and in B. Both of them. Okay? And the union, the elements are in A or in B or in both. For example,
You're going to say something about that?
You just need to remember that this is a intersection. Those are two values. Intersection D. That's the intersection. A union B. The score was 4 and 1.
Okay, for each set, what is the intersection is here? We have A and B, intersection is the union of these two events are and the elements that are in A and the elements that are in B. What elements are common? 2 and only 2?
5.
5. Okay. Yes. And the union?
Union is 1, 2, 3, 5, 1, 2, 3, 4, 5, 8, 9.
The union are the elements of B, of 8, 2, 3, 5, 8, and also the elements of B. Okay? 1, 2 is repeated in a set, doesn't matter. 4 and 9. Okay? And the elements that are in A are in B. You understand?
Formula to find the probability of B, A union B is the probability is PA plus PB minus P ampere
Okay, the last thing for today. We have two sets whose intersections is the empty set. Okay? They never meet, okay? And the probability of the union by the axiom are the probability of A plus the probability of B. If not, if A intersection B is not the empty set, then the two events meet. And then the probability of the union, the probability of the union is the probability of A, okay, plus the probability of B minus the intersection B, because here we are having the intersection twice. Okay. Then the probability is probability of A plus probability of B minus probability of A intersection. Okay. Because here we are just having.
Can you put other parentheses with PA, PB, and parentheses?
What?
Before the first B of PA and after the B of PB.
Yes.
Yeah, one parenthesis.
And after the B.
That's why.
This is good. Better. No.
We can, without this, we will try the PB and the P
Oh, then you know the
yeah. Yeah.
Yes, no necessary. Okay, this is more general. Okay. You only need to know this formula. Why? Because if the intersection is the empty set, what is this probability? Wait, if the intersection is the empty set, what is the probability of the union? Zero.
Zero.
Zero. Then you recover this formula. Okay. Any question or something? Comment? Okay, so that's all for today. Next week.